This is part 4 of the series Quadrilaterals, and we're going to start this section with the parallelogram opposite angles converse theorem, which says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Now this one might not be so easy to see as the opposite sides converse was, so let's go ahead and take a look at this theorem. Now this proof is a little complex, so I thought I'd work it ahead of time and then describe each step as we go along so that we're not distracted by the writing of the statements. So the idea behind this, we're going to use the interior angle sum theorem, actually the corollary to the interior angle sum theorem, to start this process. So we know that since angle A, B, C, and D are part of a quadrilateral, we know that the sum of the measures of those angles add up to 360. So A plus B plus C plus D is 360 degrees. Now we're given that A and C are congruent and B and D are congruent. That means the measure of angle A equals the measure of angle C, and the measure of angle B equals the measure of angle D. That's the definition of congruent angles. Now here comes the tricky part. We know that the measure of all these angles, A, B, C, and D, add up to 360. But we need to show that these two sides are parallel and these two are parallel. So what we need to show is that there's a relationship between these two angles and these two. So that's what we're going to be working through here. So I'm going to use the substitution property of equality to go from A plus B plus C plus D equals A plus B plus A plus B. Because the measure of angle A is equal to the measure of angle C. Anywhere there's an angle C, we can substitute it with an angle A. So here we copied down the angle A, and the C changed to an angle A because of this statement. Likewise, because B is equal to D, wherever we have a D, we're going to replace that with AB. So here we have angle A plus B equals angle A plus B. Now that gives us A and B, angle A and B related to each other, but we also have to have these two angles related to each other. So we're going to rewrite this statement and swap the other way around. In this case, angle A plus angle D. So because angle B is equal to angle D, everywhere there's a B, we can replace it with a D. So this B got replaced with a D in this statement, and this C is replaced by the A, just like we had up here. So we have angle A plus angle D plus angle A plus angle D again equals 360. So this is kind of a confusing part. If you need to go through that again, make sure you understand what we did here. Now for the next piece, we know that angle A plus angle A is 2 angle A, and angle B plus angle B is 2 angle B. Likewise, 2 angle A's give us 2 angle A. 2 angle D's give us 2 angle D. And that's equal to 360. We just copied that down. Now in both of these statements, we divide both sides by 2, and we have angle A plus angle B equals 180, and angle A plus angle D equals 180, and that's the division property of equality. Now you can see that we've managed to show that A and B are supplementary angles, and A and D are supplementary angles. And that's by the definition of supplementary angles, that supplementary angles are angles whose measures add up to 180 degrees. So because of this, because these two are supplementary and they're consecutive interior angles, if two lines are cut by a transversal, so the consecutive angles are supplementary, then the lines are parallel. So that allows us to say that AD is parallel to BC. Likewise, two lines cut by a transversal so that the consecutive angles are supplementary, the lines are parallel. AB parallel to DC. And that's the consecutive angles converse. So that's back to chapter 3 again. Now because we have AD parallel to BC and AB parallel to DC, we know this must be a parallelogram by the definition of a parallelogram. A quadrilateral with two pairs of opposite parallel sides. So it was a kind of a complex proof, but hopefully you got through it. If you need to go through it again, please rewind. Make sure you understand how this went because it's kind of a complicated one. And now let's go on to the next concept. In this example, we're using the parallelogram opposite sides theorem, opposite sides converse theorem actually, and we know that in order for PQRS to be a parallelogram, these two sides have to be congruent. So we know that x plus 9 has to equal 2x minus 1. So let's put that down. X plus 9 equals 2x minus 1. Then 9 equals x minus 1. 10 equals x. Same thing for this. We know that y has to equal x plus 7. We know that x equals 10, so y equals 10 plus 7, so y equals 17. And this is required for this to be a parallelogram. These two have to be congruent. These two have to be congruent. Let's move on to the next property. This proof should be a little more standard than the last one. We're going to continue the way we did before, create two triangles by drawing in AC, and ultimately proving that since these two triangles are congruent, if we can show that this side is congruent to this side, we'll be able to use the parallelogram opposite sides converse theorem to show that this is a parallelogram. Again, because we've already proven that theorem, we can now use it in the next proof. So that's what we're going to do. Let's go ahead and draw in our AC. And let's write our statement. Okay, now we can say that AC is congruent to itself. Reflexive property of segment congruence. So this is congruent to itself. And now, because we know this is parallel to this, we know this angle is congruent to this angle. So we know that angle BCA is congruent to angle DAC. And that is the alternate interior angles theorem. Now we know that these two triangles are congruent by side, angle, side. Side, angle, side. So triangle ABC is congruent to triangle CDA, and that's side, angle, side congruence. So now that these two triangles are congruent, we can go ahead and say that AB is congruent to CD. And that's by CPCTC. Corresponding parts of congruent triangles are congruent. And now, because this is congruent to this, we know that this is a parallelogram. So A, B, C, D. is a parallelogram, and this is by parallelogram opposite sides converse theorem. And that's our proof. Let's move on to the next property of parallelograms. This is the parallelogram diagonals converse theorem, and it says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Now let's go ahead and look at why this guy works. The plan for this proof is going to involve vertical angles here, showing that these two triangles are congruent by side angle side, side angle side. Then we're going to show that this side is congruent to that by CPCTC, and this angle to this by the same idea. And therefore, because this side and this side are both parallel and congruent, we'll use the parallelogram opposite sides parallel and congruent theorem to show that this is a parallelogram. So let's go ahead and get started, and we'll write down our first statement, which is angle AXB is congruent to angle DXC. Vertical angle congruence theorem. So we know this is congruent to this. Now we know these two triangles are congruent, so triangle BXA is congruent to triangle DXC by side angle side congruence. And then, since we know that these two triangles are congruent, we know this side is congruent to this, so AB is congruent to CD, and we know, so this is congruent to this, and we know that this angle is congruent to this angle, and by the same reason. So it's all CPCTC. So we know that angle BAX is congruent to angle DCX, and this is CPCTC. Corresponding parts of congruent triangles are congruent. And now we can say that because these two angles are congruent, these are alternate interior, we know that AB is parallel to CD, and that's the alternate interior angles converse theorem. And now, since this is parallel to this, and this is congruent to that, we know that this has to be a parallelogram. So A, B, C, D is a parallelogram, and the reason is parallelogram opposite sides parallel and congruent theorem. Lots of abbreviations there. I think if you analyze these proofs that we've gone through in this series alone, you can see the importance of knowing the definitions, theorems, and postulates. They're vital to being able to execute these proofs. So hopefully you've got something out of this, and let's go ahead and move on to the next section.